Hello everyone, let's solve MEXT.Math.A 2012 question 2, okay? So consider a triangle ABC. One second, let me just change the color. Okay, so consider a triangle ABC with AB equals 4, BC equals 5, CA equals 3. So let's draw a triangle. ABC. A, B, C. So BC is 5, AB is 4, and AC is 3. So let D be the point of intersection of the bisector of the angle A and the edge BC. So let's draw the bisector. So let's say that this is the bisector and this is point D. So remember that the bisector divides the angle A in two angles that are equal, okay? So, and the edge BC, find the length of AD. So what he wants is this part over here, okay? So the thing we don't know is AD is equal to what, and this is our objective. So for this, if you know the inner bisector theorem, you can just go ahead and solve this question, and you need to know the cosine law. So I'm going to review all this, okay, all the theory. So first of all, you need to know Thales theorem, okay? So teorema de Thales. So if you don't remember this one, if you already remember, jump the video a bit, okay? So if you have like these two lines, okay, so and then these lines cutting, and these lines are parallel to each other, okay? So let's draw a third line over here. So all these three lines are parallel, okay? So let's say that we have x over here, and here is 3, and we have let's say here's 6, just for it to be prettier, okay? So here's 6, here's 3, and here let's say 3, and here's 2, 2 no, and here let's say 9, okay, 9. So what does the Thales theorem tells us? That there is a proportionality. 9 divided by 3, this divided by this, is proportional to 6 divided by x, to this divided by x, by this, okay? So there is a proportionality between this and this, this and this, okay? So this is the Thales theorem. So in this case, like, this is just an example. X would be equal to 2, right? 2, okay? And you can see that the proportionality in this example, like here it was 3, if you multiply it by 3 you'll have 9, and here it is 2, if you multiply it by 3 you will get 6, okay? So the proportionality is 2. So this is the Thales theorem. Now for the inner bisector theorem. Inner bisector, okay? So for the inner bisector, let's draw a triangle over here, okay? So let's say we have this triangle, okay? And then I'm going to draw like this the bisector, okay? So this is the bisector, it divides this to alpha and this to alpha. Now I'm going to prove the inner bisector. So you see this is A, let's call this B, and this is C, okay? So what I'm going to do now is extend AC, okay? So one second. So this is just an extension of AC, okay? So if you would like, and here is the point D, okay? So this is the extension of AD, but we don't need it for now. Now what I'm going to do, I'm going to draw a parallel line. A parallel to what? Over here, I'm going to draw a parallel line. A parallel line to this line, to the line of the bisector, okay? So I'm going to draw it over here, and I can. This line that I am drawing over here, is parallel to this line. I'm drawing in such way it might not seem this, but it is parallel, okay? By construction, it is parallel, okay? So this line is parallel. So this, remember, this line over here is parallel to this line, okay? This is important for us. So why is this important? Because that's so remember that I told you that these two lines are parallel. Why is this important? Because now another thing for you to remember, okay? So this is more about a review question. So look, if you have two lines that are parallel and there is a line that is cutting them. One second. There is a line cutting two parallel lines, so this angle is alpha, this two would be alpha. And here you might remember it like this, but it is also valid in our way. We had a line over here, that is this line here, okay? This line over here, okay? And you had another line over here, which is this line over here, okay? And they are being cut by this line, which is this line over here. This is alpha, so this too is alpha, okay? So this part over here is alpha, okay? But now look, I'm going to call this point point F, okay? So look to the triangle. One second, let me draw it back. Here. So this is point B, this is point A, and this is point F. Here is alpha, okay? But look, this angle over here, this angle over here is this angle over here, okay? So this is X, okay? It's actually not X, we know it, right? It is alpha plus alpha, so it is 2 alpha. This is 2 alpha, right? So what angle is this one over here? Well, if you remember the external angle theorem, you can solve this immediately, right? But let's just prove it. Like, let's prove the external angle theorem, okay? So let's say, what was our triangle? Like this, and this, right? So this was point F, this was point B, this was point A. Here it was 2 alpha, right? Over here, 2 alpha, all this, 2 alpha. Here it was alpha, right? So let's call it here X, and this angle over here that we want to find, and this angle will be C, okay? So look, C plus X plus alpha, they are the angles of a triangle, so they are 180 degrees. So, and what's the next thing? C plus 2 alpha over here, they are in the same line. Look, this is C and this is 2 alpha, right? 2 alpha and C. So C plus 2 alpha, this is X, okay? It might seem like an alpha, but it's X. I just write the, I think I wrote, let me do it better. So just so that I don't confuse anyone. Okay, so this is X. So C plus 2 alpha is equal to 180 degrees, okay? So look, this is equal to 180 degrees and this is equal to 180 degrees, so they are equal, right? So C plus X plus, I wrote the C plus X plus alpha is equal to C plus 2 alpha, right? So C here and C here, and so alpha is equal to X, and this is the external angle theorem, that this plus this is equal to this, okay? So we just proved that this angle over here is alpha too, okay? So if this is alpha and this is alpha, so this side over here is equal to this side over here. And remember, in our question this was 4 and this was 4, okay? So why did we prove all of this? Now to solving the question, why did we do this all? Because when we extended this part over, let me draw it down. One second. Let me draw it down here. When we draw the triangle, this, and we extended this part over here, okay, and this was the bisector, okay, so remember, okay, so this was 4 and this was 3. I'm going to call this side over here y, and this side over here, all of it a, b, c. All of it was 5, right? So this part over here would be 5 minus y. So remember, we proved that this is alpha, this is alpha, and this is alpha. And then we proved that this is alpha, and then we proved that this is alpha. So this is 4 and this is 4. So why is this important? Because from you have now 2 lines, okay? Let's just analyze 2 lines, okay? So let's say that we have these 2 lines, and this is point F, okay, over here. So the line in point F here, point F, point C, and point B, and then we have 2 lines, a line cutting them, that bisector line, okay, over here. So look, this part over here is 4, right? 4. This part is 3. This part over here is y, and this part over here is 5 minus y. Now remember the Thales theorem, there is a proportionality. There is a proportionality. Why? Because this over here, the point F, the line cutting it, it is this line and this line are parallel, okay? So we have these two cutting at 2 parallel lines, so there is a proportionality between them, okay? So 5 minus y divided by 3, this divided by this, is proportional to y divided by 4, okay? So now let's find the value of y, okay? So 4 multiplied by 5 is 20, minus 4y is equal to 3y. I just multiplied like this, okay? So y is equal to 20 divided by 7. So this is the value of y. Now why did I do this? Now look, in our triangle, A, B, C, and here is point D. Remember, AB was 3, AC, I didn't like this color. Let's go with green. AB is 3, BD was y, right? But y is 20 divided by 7. AC is 4. Now, BD, yeah, better. Okay, so BD, all of BC, all of it was what? I think white is the best. BC was all 5. So now I'm going to try to find this part over here. So this part is 5 minus 20 divided by 7, right? So it would, so it is, so this will be 35 divided by 7. I just multiplied here 7 divided by 7 so that I can subtract, okay? So 35 divided by 7 minus 20 divided by 7. So 35 divided by 50 divided by 7, right? So this part over here, 50 divided by 7. Okay, now why am I doing all of this? Now look, I reach my goal. Why? This angle is alpha and this is alpha, so all that's left now is numbers. What do I mean by this? Remember, there is the cosine law, right? So if you have a triangle, let's say there is a triangle with this over here theta, and this is that's a b c. So the cosine line tells you that a squared is equal to b squared minus plus the Portuguese plus c squared minus 2 multiplied by bc cosine theta. So this is the law, okay, the cosine law. So with this you end the question. Why? Because look, you don't know the AD, right? This is, let's say this is x, okay? The thing we want to find is AD. So in this triangle over here, in this triangle over here, let me, this, the orange triangle, but not this part over here. I think you can already see this angle, this triangle, okay? So you can use this law in this triangle and the same law in this triangle over here. Why do you need to use it in both triangles? Because in both triangles you have the cosine of theta of alpha, you don't know it, and you don't know the x. What am I trying to do? Let's draw the two laws, okay? So first, the first triangle is, this is the triangle A B D, okay? So this is this part over here, not all the triangle, okay? So this part over here is 20 divided by 7, this is 3, this is x, and this is alpha, okay? So we can use the cosine theorem. So the opposite square, 70 divided by 7 squared, is equal to a squared 9 plus x squared minus 2 multiplied by 3 multiplied by x multiplied by cosine of alpha, okay? So let's do the same thing for the second triangle. So for the second triangle, now the triangle ADC. So this was 15 divided by 7, this was x, and this was 4, right? So this triangle over here, 50 divided by 7, 4, and x, and the angle was alpha, and this angle was alpha. So let's do the second one. So 15 divided by 7 squared is equal to 4 squared plus x squared minus 2 multiplied by 4 is 8 x cosine of alpha. Now you have two equations with two unknowns, okay? You have one equation number 1, equation number 2. So the rest is only numbers. You can do them by yourself. It might be messy or anything. This is x, okay? I keep doing x this way. Let me just, so this is x, okay? So look, and this is x too, okay? So look, the only thing you don't know, x and cosine of alpha, but you don't know x and cosine of alpha. So you have two variables and two equations, so you can find x. If you want to try, like, I'm not going to end it. This is only numbers, and it's really difficult to do these numbers over here. But let cosine of x alone in this equation, okay? So move everything in the other side and then put the cosine of x, the value of it that you find, cosine of alpha, over here, okay? And then you'll have an equation with only x's, okay? And then you will find the So just to make things clear, I draw the triangle over here. Okay, so this was alpha, this was alpha, and 1 second, and this over here was alpha. We proved it. This over here was alpha 2. Remember why? Because uh, the line FC was parallel to AD, so alpha here and alpha there, and as the external angle was to alpha, so both of these are alpha. Okay, so this was 4, and as it is an isosceles triangle, this is 4 2. Here. This was the epsilon, the y part, so it was 25 divided by 7, if I remember correct, and this was 50 divided by 7. Remember how we found it? It was by the relations. We used the, the that there is a proportionality, the bisector theorem, that we proved it using Thales theorem. Okay, and this part, both of this, if you sum both of this, will be 5. Okay, and this part over here was 3. Okay, so okay, so this is our triangle. So you can see, even if you don't remember, and we use the law of cosine, right? So the law of cosine, I don't need to write it over here. So I think like now you can see that you have much more information about things, and the only thing that you need to know is you need to find is AD. So I think it's really easier now.